Alright guys, in this video we're going to discuss about ionization equations and then followed by acids and bases, the basic properties. And it's going to be a very fast, really quick and simple video. So first of all, we're going to discuss ionization equations, and in Chemistry 1, first of all, we learn a molecular equation. And basically a molecular equation is one that does not involve charges. Basically, that's the basic heads up. Alright, and so now, since we're dealing with acids, bases, and ionic compounds, we want to use charges to specify, to be more specific. So we incorporate the use of charges, and then we cross out the same charges on each side, and we end up with a net ionic equation. So basically this is how we do it. I have already written down for the sake of time, but this is basically your regular molecular equation on line 1, and this describes your basic molecular equation. And what you have to do is you have to make sure your molecular equation is balanced. The states of matter are accounted for, as you can see, solid, aqueous, all accounted for right here. And right after you write this, you move on to your ionic. Well, how do you write your ionic? Well, you have to separate the compounds, some compound, mostly the ionics or the acids, into their specific charges and dissociate them. Well, some compounds you don't do that because of the fact they are insoluble, or they're weak, or weak acids or bases. So in here specifically, all of these compounds are, in fact, except for lead chloride, are soluble. Except for this is insoluble. So because it's already a solid right here. So here, what you would do here is you would dissociate each of this compound into its polyatomic ions, if you will, and separate them into this, and then you get your ionic equation. Sorry guys, ionic equation. Well, after you have done that, you have a long list of equations. Well, people don't want to see that. They want to see a basic equation. Well, so then you can cancel. You can cancel the copper. The copper is 2 pluses. You can also cancel the same ions. Remember, do not cancel. Pretend if you have an NaS and you have an Na plus on the opposite side, you cannot cancel that. Won't work, because this does not have a charge on it. This is a pure element. This is a charged element, so you cannot cancel that. But for this case, we can cancel this, and we after all, we drop these down, and we drop this down, and we drop this down, and we get 2 chloride negative plus lead 2 positive yields lead chloride. And that is how you do your first ionic equation, basically your net ionic, and that's what you get. And second of all, we can also do an element combining with water to form a base and hydrogen gas. Well, you first balance it once again, and then you drop them down, and this you just drop down because it's a solid. Liquid you drop down. All you have to worry about is aqueous. If it says aqueous, you will have to worry about it. In this case, you do actually, because you have to separate them, dissociate them into their specific separate ions. And you can just drop this down, and then you have 2 Na plus and plus 2 OH negative. And basically, what do you see here? Well, you see that none of these match. None of these can cancel out. So basically what you write is same as ionic. So that is the net ionic. It's same as the ionic equation. And same for 3. Same for 3 because you have a acid combining with a base, and what you get is water and an ionic compound, right? Well, you balance it first, as always, and then you worry about the aqueous. In this case, only this is able to dissociate. This is not, because it's insoluble based on the solubility rules given in a periodic table. And basically, after you have done all this dissociation, you have found that none of them match. So once again, same as ionic. Very basic ionic equation. Very similar to molecular, except for charges, and you have to subtract the net. But otherwise, very simple. And so yeah, we are going to discuss now because of the fact that acids and base, they are always aqueous, right? And when you're dealing with acid, you don't know if you want to dissociate this, right? Because this does not apply in the solubility rules. Well, here's a rule for it. In acids and base, the rule is when you have a strong acid and a strong base, it will be soluble. If you have a weak acid or base, either one of those, they will be insoluble. So basically that is the rule, and this is what you have to memorize. These are the strong acids. So HClO4, HCl, HI, HBr, HNO3, H2SO4, all these are strong acids, and the most common of those. So this is practically what you use in chemistry 1. So the teacher won't usually ask something out of this realm. So if it's not one of these, it should be a weak acid. Now for bases, you have this. Now this may seem a lot to memorize, but when you look at it, it's actually pretty easy because there is a pattern involved. When you see here, you see lithium. All of these have oxides, of course, but when you have lithium, sodium, potassium, rubidium, cesium, calcium, strontium, and barium. Well, when you look at this periodic table, what do you see? All the elements come from here. All the strong bases come from here. So when you see a base, look in the periodic table. If the first element is one of these 2 rows, it should be a strong base. Otherwise, if it's from here on out, it should be a weak base. And that is how you do it. And so now let's move on to acids and bases. Well, acids and bases are pretty basic, and what you have to do is we're just going to discuss the properties first. So let's discuss the properties. Well, we have acid, right? So people, when they started classifying acids, they noted that it had sour taste, and it turned litmus paper red. And there was 2 properties of the acid, and it also reacted with bases to form salts and water, and it was electrolytes. All acids are electrolytes. Now when we go to base, we note a bitter taste turns litmus paper blue, feels slippery, and it also reacts with acids to form salts and water, and it's also electrolytes. Pretty basic. This is the beginning of an acid and base, just basic properties. Now we go on to common acids. This is the last part of this video. Common acids, basically, you have to memorize them, are these: sulfuric, acetic, nitric, phosphoric, and hydrochloric. All of these are the most common acids produced in the world, and that is why they are given a section. So first of all, we begin with sulfuric acid, which is the most commonly produced acid in the world. It's used for petroleum refining, and it's also used for metallurgy, which is the art of metal making, or making of iron, steel. You use sulfuric acid, and it's also used in fertilizers. Now we move on to acetic acid, and acetic acid, you find it in vinegar, and it's also used to make plastics and food supplements. You move on to nitric acid. Now, nitric acid is an unstable acid. It's not used in the laboratory in its pure form, and it's used to make explosives, plastics, and pharmaceuticals. In fact, dynamite uses nitric acid. Phosphoric acid is used in fertilizers, beverages, and detergents. And finally, hydrochloric acid. It's most commonly gained the most fame because it is produced in your own stomach. Your own stomach produces hydrochloric acid to digest food. It is also used to pickle iron and steel. And what does that mean? Well, pickling iron and steel is because when you create a piece of iron, let's say a piece of iron, you have these deformities, right? And when you soak it in a little bit of hydrochloric acid, you get rid of all these deformities, and you leave it with a clean sheet of iron. Now, not too much because it'll just burn through the iron, but a little bit will just pickle it and get it to the right form. Now, it's also used as a cleaning agent, and when it is diluted, usually it's called muriatic acid, and it's used in pools to filter out the pool and the bacteria from the pool. So basically, that is it for this section of chemistry. And yes, subscribe and eat Jama University.